Hello, this is Satbir. The topic of our discussion in this video tutorial is integrating factor of differential equation. Let's start the video tutorial with the discussion of what is a integrating factor. Let's suppose we have a differential equation, the first order differential equation, which can be written in this form. The function of m, function of x comma y, m dx plus a function n, which is a function of x comma y, and dy is equal to 0. And we know that if the partial derivative of the term y with respect term m with respect to y is equal to the partial derivative of n with respect to x, if these two partial derivatives are equal, then the differential equation is exact. And we learned a technique in the previous video how to solve a differential equation which is an exact differential equation. But if the partial differential equation we have under consideration does not satisfy this property, or in other words, the partial differential equation is not exact. In this case, we cannot find the solution of these type of differential equation using the previous method. However, maybe there is a way to fix this this exactness, and if we can find maybe a possible to find a factor which is a function of x comma y. If I multiply these function, if it is possible to find a function when I multiply throughout the differential equation y dy, if this differential equation turn into exact, and this will solve our problem. So we will look for a function in order to fix the exactness. If we can find a function which is a function of x and y, we multiply throughout the differential equation, and this turn the differential equation into exact. Or in other words, the partial derivative of this term, the very first term with respect to y, mu m, is equal to the partial derivative with respect to x of the term mu n. Then we call this very special function mu x comma y is our integrating factor, IF, or sometimes it is called the integrating function as well. Let's take an example and see that is there a these type of function exist, and in the next video we will learn that how to find these type of function which make the differential equation exact. I have this differential equation. First I'm going to write this differential equation into a mdx plus nd form. So if I multiply both sides by dx, then I get this form. Y square dy is equal to 0. Clearly in this case, this is our m and this is our n. If I calculate partial derivative of m with respect to y, this will be 3x square y square, and the partial derivative of n with respect to x, it will be 1 plus y square. So these two partial derivatives are not equal, so this differential equation is not exact. Now to fix the exactness, there may be a function mu. If we multiply that function on both sides, it will fix the non-exactness of the differential equation. And in this case, this function is given, but most of the cases we have to find this function. So let's try first to see that, to verify that whether this function is a integrating factor or not. In order to do that, what we will do, we will multiply by this function throughout. is going to be x square y cube divided by x y cube dx plus x 1 plus y square. Whole thing is divided by x y cube dy is equal to 0. Now there will be some simplification here. So if I simplify, this is going to be x, y cancel out, and this 1x cancel out. Then this is a dx plus this x cancel out. So 1 plus y square y cube dy is equal to 0. Now we can choose our new m. So this is our new m and this is a new n after multiplication. So if I calculate the partial derivative of m with respect to y, it is 0 because n has no y in it. And if I take the derivative of n with respect to x, this is also 0. That implies the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. Now this new differential equation is an exact differential equation. So since this is a differential equation in exact, we can use the technique which we learned in a previous video to find the solution of this differential equation. So as you can see, this function is a really important function because it helps us to find the solution of a non-exact differential equation. In the next video, we will find some techniques to find a function of to find this function, which is the integrating factor of a given non-exact differential equation. Here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. This is also the end of this video. Thank you very much for watching. I will see you in the next video. Bye for now.